How do, how can I balance this reaction? Silver 0 going to silver plus 1 electron. So nitric acid is acting as an oxidizing agent to oxidize silver to silver plus. So 1 mole, this reaction you have to multiply by 3 to make the electron change equal. Alright? So 3 silver, 1 nitric acid will give me what? 3 silver nitrate. Silver has to be, silver goes to 0 to plus 1. Where is the anion? The nitrate is the anion.
Yes.
1 mole of nitric oxide. Now, 1 mole of nitric oxide converts into 1 mole of nitric oxide. 1 mole of nitric acid gives 1 mole of nitric oxide. And I need additional 3 nitrate ions. So 4 moles of nitric acid. So 1 mole of nitric acid oxidizes silver to silver plus and get reduced to nitric oxide. Now 1 mole of nitric acid will react with 3 moles of silver to form 3 silver ions and 1 nitric oxide. The silver ion requires the anion. The anion is provided by nitric acid. So I need an additional 3 moles of nitric acid to provide 3 nitrate ions to 3 silver ions. So the total number of nitric acid will be 4 instead of 1. Nitric oxide is a colorless gas. It goes out, and when you crystallize, on evaporation, you get a colorless crystals of silver nitrate. Silver nitrate, when you heat it gently, so silver nitrate, if I gently heat it, it will convert into silver nitride and oxygen. But if I heat it strongly, it will give silver, nitrogen dioxide and oxygen. Silver nitrate solution, when is added to solution of sodium halide, silver halide precipitate, except silver fluoride, which is water soluble. Silver fluoride is not give a precipitate. It is because it is water soluble. But all other halides will give a precipitate. Silver chloride is a white precipitate. Silver bromide is pale yellow precipitate. And silver iodide is yellow precipitate. So you can see that if you get a white precipitate, it indicates chloride. If you get a pale yellow precipitate, it's a bromide. And if it is a yellow precipitate, you get iodide. Silver chloride.
Sir, why that AgBr is pale yellow? If their Ag is in D10 configuration, then why not it is colorless or white?
As the electronegativity decreases, the ease of transfer of electron increases. So the energy required to transfer the electron from chloride to silver falls in the ultraviolet region, so it is white. But as the energy of electronegativity decreases, the ease of electron transfer from halide to silver decreases, so it falls now partly in the visible region, so it is pale, and when it comes to iodide, it is fully in the visible region, so it is intensity is 4.
Yes.
Silver chloride is soluble in dilute ammonium hydroxide to form diamine silver chloride, AgNH3 twice Cl, which is water soluble. Silver bromide is soluble in concentrated ammonium hydroxide, and silver iodide is insoluble in ammonium hydroxide. The solubility of silver halide, the solubility in water of silver halide decreases from silver fluoride to silver iodide, because as the size of the anion increases, polarizability increases, and silver ions has a good polarizing power, thus turns silver iodide to a covalent compound.
Yes.
So as the size increases, the covalency increases, solubility decreases.
Yes, sir.
Provided the cation has a good polarizing power, and silver has 20 d electrons, 3d10, 4d10. So because of the imperfect shielding by the d electrons, silver has a good polarizing power. So as the size increases, the polarizability increases. As a result, the covalency increases. As the covalency increases, the solubility in a polar solvent decreases. As the covalency increases, with increase in size of the anion, the solubility in polar solvent decreases. Why silver fluoride is water soluble? Because fluorine is most
Yes.
so the compound is ionic. Since silver fluoride is ionic, so it is soluble in polar solvent.
Polar solid.
As the size of the anion increases, the covalency increases, solubility decreases.
Decreases.
So if I add sodium thiosulfate to silver nitrate, sodium thiosulfate is colorless, silver nitrate is colorless. If I add, I get a white precipitate of silver thiosulfate. If I add more of sodium thiosulfate, the silver thiosulfate dissolves to form bis thiosulfate complex of silver 1, and which is water soluble. So the precipitate dissolves.
Yes.
But if silver thiosulfate is allowed to stand on standing in presence of air and water, silver thiosulfate, when it's present, is it forms silver sulfide and sulfuric acid. And silver sulfide is black. So if the white precipitate is allowed to stand in water for some time, it converts silver thiosulfate white precipitate to black, silver sulfide and sulfuric acid is colorless. So the white precipitate turns black.
Black.
Silver thiosulfate, silver nitrate, when you add to sodium chromate, silver nitrate, when you add to sodium chromate, you get silver chromate and sodium nitrate. And silver chromate is a red precipitate. Sodium chromate gives two types of precipitate, yellow and red. The red precipitate is silver chromate. And yellow precipitate is lead chromate or barium chromate. They are yellow precipitate.
Yes.
So sodium chromate gives two types of precipitate. One is a red precipitate, which is silver chromate, and you get a yellow precipitate, which could be either lead chromate or barium chromate.
Yes. Yes, sir.
Silver bromide is used in photography. So you take a film and a silver bromide suspension is added onto the film. So the film is coated with silver bromide. Now when you open the shutter, when you click the shutter, when you press the button, the shutter is open and the visible light falls onto the silver bromide of the film. Silver bromide converts into silver and bromine radical. So the bromide ion goes to bromine radical and releases electron, and silver plus electron gives metallic silver.
Yes.
So the silver bromide gets converted to metallic silver. The metallic silver is now assembled together, joined together to form a small crystal of silver. Immediate portion of the film, that is next to the portion which is not exposed to white light, but is exposed to the diffused light, they are partially reduced. So the portion which is immediate to the where light was fallen directly, the portion of the film which is next adjacent to that is affected by the diffuse light. As a result, it is not completely reduced, it is partially reduced.
Yes.
Now, a developer is used. So the silver bromide, which was partially reduced, was completely reduced by a mild reducing agent called hydroquinone,
Yes.
which reduces partially reduced silver bromide to metallic silver. And now all joined together to form an image of the object. The excess silver bromide, they are removed. The unaffected silver bromide are removed by the addition of sodium thiosulfate, which is called fixer. So silver bromide precipitate is dissolved by sodium thiosulfate to form a bis thiosulfate of silver argentate complex. Sodium bis thiosulfate argentate 1 complex, which is water soluble. So excess silver bromide is washed off from the film, and so you get the image of the object. And that is how the photography is done. So in photography you use three different type of material. One, silver bromide, which forms an emulsion on the film. Second, you use a developer which is a mild reducing agent to partially reduce silver to metallic silver. And the third, you use a fixer to dissolve the unexposed silver bromide from the film to form a water-soluble bis thiosulfato-argentate complex. So now, in the film, onto the film, what you have is metallic silver, which forms an image of the object and the transparent portion of the film. That means where the silver bromide is washed off. And that is used in principle used in photography.
Excuse me, sir. Sir, that reaction of conversion of EGBr into that free radical. Sir, does that reaction occur only for some specific wavelength of the light?
Which one?
Sir, the first reaction, EGBr gives.
The first reaction occurs only when the light directly falls onto the film. So when the light falls onto the film, the silver bromide gets reduced to metallic silver. The bromide gives an electron to metallic silver to reduce silver plus to metallic silver.
So this reaction occurs for all wavelengths of light or only for some specified wavelength?
Visible light. Silver fluoride is sensitive to UV light, but silver bromide is sensitive to visible light. Now we go to iron. Iron is the second most abundant metal on Earth's crust after aluminum. The ores of iron is Fe2O3, that is hematite, Fe3O4, that is magnetite, that is FeO.Fe2O3. Siderite is also known as spathic iron. In Fe2, iron is not in class 4, class 2 oxidation state, and S2 is 2 minus. And it is diamagnetic because Fe2 is D6 and D6 strong field will give you diamagnetic. So S2 2 minus acts as a strong field ligand, so it pairs all the 6 electrons and so it becomes diamagnetic. So in iron pyrite, the iron oxidation state is +2, not +4.
Yes.
It is +2 and S2 2 minus acts as a strong field ligand, provides pairing energy, pairs all the 6 electrons to become diamagnetic. Now you write down the reactions occurring in the blast furnace. That is at the upper part of the blast furnace. Finish quickly, write down quickly because otherwise it will take time. After writing down whatever question you have, you ask me. First write down.
Excuse me, sir. Sir, in that case of use of EGBr in photography, so if that was the case, then on the negative we would be able to see only 2 colors, like one would be black and one would be white. But instead we also see some greenish and pinkish patches also.
No, that is when you use a colored film. This is for black and white.
Okay. Yes.
So what you have to remember that what are the reactions taking place at what temperature range. When the temperature is low, carbon monoxide is a reducing agent. When the temperature is high, carbon acts as a reducing agent. So at lower temperature, Carbon monoxide reduces ferric oxide to iron, which exists in the form of a solid because iron has a higher melting temperature. At a higher temperature, the iron melts and the impurities from phosphate and the silicate, they are reduced to phosphorus and silicon, and they get dissolved in the molten iron to give the impurities. At the heart of the furnace, that is the lowest section of the furnace, the carbon plus oxygen to combine to give you carbon monoxide. So what is your charge? Hematite, sand, and limestone.
Yes.
So the first reaction at 200 to 700, limestone decomposes to give the calcium oxide plus carbon dioxide. When you add sand, the silicon dioxide reacts with calcium oxide to form calcium silicate, which floats onto the surface and does not allow the oxygen to come and oxidize iron to iron oxide.
Yes, sir.
The iron which you get in the blast furnace is called pig iron. You melt and put it in molds and cool it, you get cast iron. So cast iron is nothing but pig iron melted, remelted pig iron. Cast iron, there are two types of cast iron. The white cast iron and grey cast iron. When you cool it, rate of cooling, when you first cool it, on first cooling, you get white cast iron, where carbon is present as cementite, iron carbide. When you slow cool, on slow cooling, you get carbon in the form of graphite. And you get grey cast iron. So whether you get a white cast iron or a grey cast iron depends upon the rate of cooling. The first cooling, you get white cast iron, where carbon is present in the form of iron carbide, which is called cementite. And on slow cooling, you get carbon is present in the form of graphite, is called grey cast iron. Carbon percentage. Cast iron, mild steel, hard steel, and wrought iron. Cast iron is about 2.5 to 4%. Mild steel, 0.2 to 0.5%. Hard steel, 0.5 to 1.5%. And wrought iron is 0.15 to 2.25%. So the wrought iron is the purest form of iron, which has minimum carbon impurity. Cast iron has a melting point 1250 degrees Celsius, whereas wrought iron has 15 degrees Celsius. So as the impurity increases, the melting point decreases. So lower the impurity, higher is the melting point. So you can see the wrought iron, the cast iron is hard but brittle. It cannot be welded or magnetized easily. because of its presence of impurities in large amount, but it is corrosion resistant and it expands on cooling, hence used for casting. Wrought iron is soft, ductile, can be welded and magnetized easily. They can be used for making permanent magnets. Preparation of wrought iron, which is known as puddling process. You take cast iron and heat it with ferric oxide, which acts as an oxidizing agent. It oxidizes, ferric oxide oxidizes the impurities present in cast iron to make wrought iron. So ferric oxide acts as an oxidizing agent. It oxidizes the impurities present in cast iron and converts the cast iron into wrought iron. And this is known as puddling process. Now write down the alloys of iron.
Sir, excuse me, sir. Sir, during the oxidation of cast iron to wrought iron, why not all the carbon is oxidized? Some percent, why is there remaining?
Because ferric oxide has a limited oxidizing property. So it removes most of the carbon, but a trace of carbon is still retained in the form of cement type of thing. So it is not altogether free. And that is why you can see that wrought iron has a melting point 1500, whereas melting point of iron is 1535. So it is slightly less than that of iron, pure iron. So it is one of the purest form of iron is wrought iron.
Yes.
How is cast iron resistant to corrosion?
Because of presence of impurities, the iron does not undergo corrosion very easily. The reactivity of iron is decreased due to the presence of impurities. And that is why all rainwater pipes are made of cast iron. If you throw a stone, it will break. But it is, because it is corrosion resistant, so it is, all rainwater pipes earlier days were made of cast iron. Today it is made of polythene tube pipes, but earlier building, if you see, they are all made of cast iron.
Yes.
Involved is made of iron and nickel. It has a low coefficient of expansion. As a result, the wall clock, the pendulum of the wall clock is always made of involved. Stainless steel is iron, chromium, nickel with 1% carbon. Finished or not? Yes. There are 4 vitriols: copper sulfate, pentahydrate, blue, zinc sulfate, white vitriol, ferrous sulfate, 7 water, green vitriol, and sulfuric acid is oil of this. Which helps crystallization of ferrous sulfate and prevents oxidation of ferrous sulfate to ferric sulfate. Ferrous sulfate Heptahydrate is a green, light green crystals. Can you read now?